All right, so in lesson 414, we're going to talk about how to calculate outliers. We've talked about outliers and what they are and how to look and kind of identify if you think there might be one. But now we're going to look at how to calculate it mathematically. Remember, if there's an outlier, it will affect the mean, which means the median is not as influenced by outliers because it's not an average. So what we want to do is look at how to calculate that. So the first thing we're going to do is we're going to look at this data set. Each student in Mr. Lamb's class measured a pencil. The data set below shows the pencil length in centimeters. What is the expected length of any given pencil? So the expected length would basically be the average length, unless there's an outlier, in which case you would want to say the median length would be your best guess or your best choice for the length, right? And then we also want to describe the shape, center, and spread of the data. So what we're going to do is just kind of glance over these, see if there's any of them that stand out to you. The only one that I see that looks questionable to me is this one right here, this 10.2. Now, it's relatively close, but remember, we're talking about some very, very small, minute differences between these pencil lengths. So that one does seem a little bit further away from the group. So let's calculate IQR and use that to find whether there is or is not indeed an outlier. So for that, I'm going to swap over again to my camera because I want to use the calculator because it makes your life a lot easier. So data, I already plugged in all these numbers. Again, make sure you get them all. There's 20 of them. I got all 20. Okay, so there they are. So second, data, one variable stats. We'll get to two variable, don't worry, but we're not there yet. I plugged in everything into L1 and then hit calc, and it gives me a list of numbers. Okay, so my mean is 16.03. And if there is an outlier, then this number is not going to be your best representation. If there's not an outlier, then this probably is your best representation. So how do we find the outliers? So here we go. We're gonna write down some of these other numbers. So we're gonna write down the minimum. So the min is 10.2. Q1, which is gonna be very important. Q1 is 15.6. The median is 16.1. Q3 and the max are the other two that I need. So that's 17 and 19. Okay, and I'm also going to write down my IQR, which is 17 minus 15.6. So that is 1.4. All right, now we have not talked about how to calculate outliers, but here's what you do. Okay, to do your outlier is going to be 1.5 times your IQR, and then you're going to subtract that from Q1 and add it to Q2. So for a lower outlier, you are going to do Q1 minus 1.5 IQR, okay? Which in our case would be Q1, which is 15.6 minus 1.5 times 1.4, okay? Now, on the upper side of things, we're going to do the same thing. So upper outlier, and this is what you're looking for is anything that's beyond this number, right? Anything below this value and anything above the next value. So Q3 plus 1.5 times IQR. So that would be 17 plus 1.5 times 1.4. So if we multiply and clear that up, we got 1.5 times 1.4, which I'm not doing actually. 1.5 times 1.4. So it's 2.1. So that would be 15.1 minus 2.1, which is going to be 13.5. And then down here, that's 17 plus that, which is 19.1. So what I want to do is I want to look for any numbers below 13.5, which is 10.2, and then anything above 19. So if I go back, I had a 19, but not 19.1. So nothing above that, so none. So 10.2 is my outlier, which means we do not want to use the mean. We want to use the median, okay? So the expected length is 16.1 centimeters. Okay, and we got that from the median. Now, to measure spread, the easiest way to do that is to draw yourself a number line, do your box and whisker plot. We already have all the information for it. So we're going to start at 10 and count by twos, 12, 14, 16, 18, 20, 22. I didn't need to go anywhere near this far, but that's okay. All right, so 12, 14. Probably should have renumbered it, but it'll be fine. We don't need to go anywhere further, so we really don't even need the rest of that. Okay, so that's a good reason why you should use pencil, not pen. Now, lowest value is 10.2, so it's going to be basically right here, right at that 10. Next value is Q1, which is 15.6. So 15.6 is going to be right in there somewhere. 16.1 is basically right here. And then 17 is halfway. And you should see a pattern of what happened here. Biggest value being at 19. There's your box. So what do you notice about the box and whisker plot? What I'm hoping you're going to say is that this tail is way longer than everything else. That's because that outlier is dragging that final value down. Okay, so we're going to stop there with that video. Again, we calculate the expected length. So your spread is pretty good between this area. There's a giant spread over here, probably caused by that outlier. Well, it is caused by that outlier. Okay. So what should you do with that value if you're really trying to clean up this data set? You should just be aware of it, right? Because you don't want to make a decision based on an outlier, because it's not going to be the best decision possible. Okay, so pause this one here and move on to the other two examples in the next one.